The polar vortex is a massive, icy swirl of supercold air building up in the upper atmosphere since August. You can think of it like a colossal winter storm waiting to shake things up in the northern hemisphere. Until now, a powerful wind current called the polar jet stream has been holding it back. But this jet stream has been weakening steadily. Now it's time to ring the alarm bells. The polar vortex has just collapsed and something terrifying is happening. You may have to brace yourself for a blast of freezing air across the United States, Canada, Northern Europe, and Russia, but before that, let's take a look at what's actually happening and how big of a deal is it. The polar vortex is a meteorological phenomenon observed above both the north and south poles of our planet, thus the name. It is essentially a large, swirling mass of extremely cold air in the stratosphere above the Earth's poles. This rotating low-pressure system has a counterclockwise circulation around the North Pole and a clockwise circulation around the South Pole. Since August 2023, this frigid air mass has been steadily accumulating and gaining strength. This buildup sets the stage for potential disruptions in the atmospheric dynamics, with implications for winter weather patterns, especially in the Northern Hemisphere. The polar vortex can significantly influence winter weather conditions in regions such as the United States, Canada, Northern Europe, and Russia. But there is one thing keeping it all in check. That's the polar jet stream. This is a high-altitude, fast-flowing air current that encircles the Earth near the poles. You can visualize it as a meandering ribbon of air that acts as a barrier, keeping the polar vortex in check. Historically, it has been crucial for preventing the collapse of the polar vortex. However, if the jet stream weakens significantly, it may fail to contain the polar vortex, potentially leading to its collapse and the release of bitterly cold air into the northern hemisphere. This collapse will release an icy air surge, heralding a winter unlike anything witnessed before. Understanding the implications of the polar vortex is crucial for anticipating and preparing for the atmospheric changes that may unfold in the coming months. Before we dive deeper into the imminent climate disaster that awaits, let's take some time to understand what the polar vortex is and why it matters. The polar vortex is a low-pressure system marked by a mass of extremely cold air, with temperatures significantly lower than the surrounding regions. The system is dynamic and ever-changing, influenced by various atmospheric factors. It originates and intensifies during the winter months, particularly in the northern hemisphere. As the temperatures drop, the air above the polar regions becomes colder, leading to a high-pressure area. This sets the stage for the polar vortex to begin forming. This swirling vortex rotates in response to the Earth's rotation on its axis. The exact phenomenon determining this rotation is the Coriolis effect, which is the apparent deflection of moving objects, including air and water currents, caused by the rotation of the Earth. In the northern hemisphere, objects tend to be deflected to the right, while in the southern hemisphere, the deflection is to the left. This, in turn, causes the vortex to rotate counterclockwise above the North Pole, while around the South Pole, it rotates clockwise. The polar vortex is encircled by strong jet streams, particularly the polar jet stream, which acts as a boundary separating the cold air within the vortex from the comparatively warmer air in the middle latitudes. These jet streams keep the cold air from spreading too far southward. The interaction between the polar vortex and these jet streams is a dynamic interplay that shapes the vortex's behavior and influences its stability. But when things go wrong, the vortex can, as it has in the past, collapse. The collapse of the polar vortex is tied to temperature and pressure differences between the equator and the poles. The Earth's rotation causes uneven distribution of sunlight. Thus, the air above the equator tends to be warmer, creating a low-pressure system, while the air above the poles is colder, resulting in a high-pressure area. These disparities force the cold air from the polar vortex to move toward the warmer equator where there is more space, if nothing is holding this cold air back. The ongoing tug-of-war between these temperature-driven pressure systems contributes to the vulnerability of the polar vortex. The weakening of the polar jet stream, as noted earlier, is closely linked to the potential collapse of the polar vortex. If the jet stream loses strength, it may allow the polar vortex to extend its influence farther southward, leading to disruptions in normal weather patterns and the possibility of a collapse. And this is not unprecedented or theoretical. Polar vortex collapses occur with a notable frequency. These events are anything but rare. Instead, they are a part of the natural variability in Earth's climate system. Polar vortex disruptions result in shifts in weather patterns, especially during winter. These collapses tend to happen every few years. However, the exact frequency is influenced by a combination of atmospheric conditions and external factors. Plus, the intensity of these collapses can also vary. While milder disruptions are not as big of a concern, more severe events can have a profound impact on weather systems. Throughout history, there have been several severe polar vortex collapses, each leaving a lasting impact on weather patterns and regions affected. One of the most significant historical collapses was associated with the Great Blizzard of 1899. This event ranks among the worst storms in U.S. history and was marked by extreme cold temperatures and heavy snowfall. It also led to widespread disruptions, affecting transportation, agriculture, and daily life. Similarly, the collapse in December 2012 and January 2013, triggered by a sudden stratospheric warming event, resulted in a massive blizzard in the tri-state area and colder-than-average winter conditions in the UK. Such collapses of the polar vortex have had profound impacts on weather patterns and the regions they affected. Severe disruptions to the polar vortex can result in exceptionally cold temperatures, blizzards, and extended periods of winter. The consequences are often felt most acutely in high-latitude regions, including the United States, Canada, Europe, and Russia. The recurrence of such events highlights the importance of studying and anticipating the behavior of the polar vortex. It all usually starts in August, which marks the beginning of its annual development process. During this period, extremely cold air begins accumulating in the stratosphere above the polar regions. The timeline from August sets the stage for the subsequent strengthening and potential impacts on winter weather patterns. The polar vortex reaches its peak strength around December, which aligns with the peak of winter when stratospheric temperatures are at their lowest. As the mass of cold air intensifies and gains momentum, its influence on atmospheric circulation patterns becomes more pronounced. This is true for the present situation as well. Observations indicate that the vortex is rapidly strengthening as the winter draws on. We got an early confirmation in 2023, providing us with valuable data to monitor and analyze the trajectory and behavior of the polar vortex in the coming months. There is thus a baseline for ongoing assessments and predictions, enabling scientists to refine their understanding of the vortex's characteristics and potential deviations from typical patterns. Efforts to forecast and prepare for the atmospheric dynamics associated with the polar vortex in the foreseeable future are underway. Recent observations have also rung alarm bells. There is clear a weakening trend in the polar jet stream, raising concerns about its ability to maintain its barrier function. This weakening trend raises the ominous possibility of a collapse. The implications of such a collapse are horrifying as the Western world is already grappling with an energy crisis and lack of proper building insulation. The release of an intense surge of icy air into the northern hemisphere will bring unprecedented winter conditions to the region. This will extend even to areas that are not accustomed to extreme cold. Plus, it's not just the jet streams. Sudden stratospheric warming events also play a pivotal role in triggering polar vortex collapses. The rapid increase in temperatures in the stratosphere, specifically above the polar regions, can lead to disruptions in the normal circulation patterns of the polar vortex, potentially causing it to weaken and eventually collapse. The mechanisms behind sudden stratospheric warming events are complex and often involve interactions between atmospheric waves and other meteorological factors. One key factor affecting the polar vortex's strength is the El Niño. El Niño is a climate phenomenon characterized by the periodic and abnormal warming of sea surface temperatures in the central and eastern equatorial Pacific Ocean. This alters the normal patterns of atmospheric circulation and has far-reaching effects on global weather and climate. These events occur irregularly every few years and can last for several months. They lead to a disruption in the normal atmospheric circulation patterns, influencing weather globally. It alters rainfall patterns, leading to droughts in some regions and increased rainfall in others. El Niño can trigger floods, hurricanes, and heat waves, impacting agriculture, ecosystems, and economies worldwide. Regions bordering the Pacific Ocean, such as South America, Southeast Asia, and Australia, are significantly affected by such events. One of the notable links between El Niño and polar regions is the transmission of heat waves towards the poles. During strong El Niño events, the warmer-than-average sea surface temperatures generate heat waves that move toward the poles. These heat waves extend into the stratosphere, contributing to sudden stratospheric warming events. The warming effect induced by the interaction between El Niño and the stratosphere establishes a link between oceanic and atmospheric conditions. Strong El Niño events generate more powerful heat waves that increase the likelihood of sudden stratospheric warming. As a result, the polar vortex becomes more susceptible to disruptions, potentially leading to its weakening or collapse. On top of this, El Niño events are also tied with the disruption of the jet stream. The intense heat waves generated by El Niño contribute to the destabilization of the stratosphere above the poles, leading to alterations in the jet stream's strength and pattern. A weakened jet stream is less effective in containing the polar vortex, allowing the frigid air to extend further southward. The disruption of the jet stream and subsequent impact on the polar vortex are key components of the chain reaction initiated by El Niño-induced heat waves. This disruption can have cascading effects on regional and global weather patterns, influencing temperatures, precipitation, and storm systems. The correlation here highlights the interconnected nature of global climate phenomena, with events in one part of the world influencing atmospheric conditions in distant regions. The strength of El Niño events thus becomes closely associated with the risk of polar vortex disruptions. Back to present times, September marked a confirmed El Niño phase with moderate strength. Meteorological observations and climate models indicated a high likelihood of the ongoing El Niño phase escalating into a strong event by the end of 2023 and the start of 2024. This has proven to be true. As stratospheric temperatures continue to drop, the heat waves generated by the intensified El Niño are expected to strengthen even further. This escalation holds implications for atmospheric circulation, weather systems, and the potential for extreme events in affected regions. The El Niño is anticipated to peak between January and February of 2024. During this period, the influence of El Niño on climate dynamics is expected to be most pronounced. Naturally, recognizing the phases and potential escalation of El Niño is important for proactive climate monitoring and the implementation of adaptive measures for when the polar vortex collapses. So, what should we expect? A collapse of the polar vortex leads to immediate and severe consequences, such as exceptionally cold blizzards. The sudden release of frigid air from the polar regions results in intense snowfall, strong winds, and harsh winter conditions. These blizzards can disrupt normal life, impede transportation systems, and pose significant challenges to infrastructure and public safety. Another short-term consequence of a polar vortex collapse is a record-setting low temperature. The frigid air mass unleashed by the collapsing vortex brings sub-zero temperatures to regions that may not usually experience such extremes. Record lows can have widespread implications affecting agriculture, energy consumption, and the well-being of both human and animal populations. Countries and areas in North America, Europe, Canada, and Russia are particularly vulnerable to the consequences of a disrupted polar vortex. These regions are at a heightened risk of extreme cold events. Specific impacts may include disruptions to transportation networks, increased energy demand for heating, challenges to agriculture, and potential strain on emergency services. The recognition of this threat is crucial for governments, communities, and individuals to understand the potential risks associated with extreme weather events, frigid temperatures, and disruptions to normal life. Despite the challenges posed by the unpredictability of the polar vortex's behavior, preparation remains of paramount importance. Since there are limited options for directly controlling or preventing a polar vortex collapse, we need proactive measures to enhance resilience and minimize the impact on affected regions. Preparedness efforts can include infrastructure improvements, emergency response planning, and public awareness campaigns to ensure the safety and well-being of communities. Moreover, the behavior of the polar vortex is inherently unpredictable, and its collapse may occur with limited forewarning. This makes it challenging to precisely anticipate the timing and severity of a collapse. The unpredictability of the whole thing reinforces the need for constant monitoring, research, and adaptive strategies that can be swiftly implemented in response to evolving conditions. However, recognizing the potential risks enables the development and implementation of general preparedness measures. Despite the limited ability to control the vortex's behavior, there is room for mitigating the short-term and long-term consequences associated with its collapse. The timing just couldn't have been worse for the Western world. The potential collapse of the polar vortex, combined with the current energy crisis in Europe which stems from Russia's invasion of Ukraine, presents a dire situation for the countries that stand to be affected the most by the upcoming record-low temperatures. The economic fallout of Russia's invasion of Ukraine has been severe, with profound implications not only for both nations but also for the global community. Ukraine witnessed a drastic decline in economic output, losing 30 to 35% of its GDP in the first year of the conflict. This led to the largest recession in its history, pushing 7.1 million more people into poverty, reversing 15 years of progress. The war's impact on agriculture, once a cornerstone of the Ukrainian economy, has been particularly damaging, disrupting production and exports. But things don't end here. The war forced over 6 million people to flee Ukraine, creating a significant workforce shortage and leaving behind a devastated national economy. The recovery outlook is uncertain, contingent on the war's duration, which seems to drag on for now. In Russia, the impact of global sanctions has been significant, causing a decline in GDP and triggering financial difficulties. The manufacturing sector witnessed shifts, with a decline in overall output but a rise in the production of goods related to the war. Russia's budget allocation highlights a prioritization of military spending over essential public services, indicating the redirection of resources. However, the aftershocks of the conflict have spilled over to the rest of the world as well. The war has exacerbated the cost of living crisis, contributing to soaring inflation rates, and particularly affecting the poorest populations. Food security has been compromised, with disruptions in wheat and sunflower oil exports from Ukraine and Russia. But most importantly, the conflict has led to a rise in energy prices, impacting international markets. This is a direct consequence of European markets reducing their reliance on Russian energy sources. Initially focused on post-pandemic recovery and a strengthened green agenda, the EU's response to Russia's invasion of Ukraine has showcased political unity and unanimously imposed 11 packages of sanctions on Russia. However, these sanctions don't just hurt Russia. Since the European continent relied almost entirely on the Russian Federation for its gas imports, sanctioning this sector has spelled out an energy crisis for Western nations. While the EU nations and the UK have taken measures such as diversifying gas supplies, coordinating demand reduction, and accelerating renewable energy development, economic troubles loom large. During the unforgiving winter months, it's either heat or eat for many Europeans. And things are about to get a whole worse. As Europe grapples with the transformative effects of the Ukraine conflict, it is evident that energy market reforms may not be enough in the short term. The specter of a very cold winter triggering a spike in gas consumption looms, especially considering the uncertainty surrounding Russian gas deliveries to southeastern Europe. A sudden stratospheric warming event, influenced by the ongoing El Niño, could disrupt the polar vortex, impacting the northern hemisphere at a time when it can hurt the most. Any strain on the gas supply due to a harsh winter will amplify existing concerns about energy prices. Last year, the energy crisis hit the European Union very hard. The EU faced challenges in securing a stable and affordable energy supply, leading to various consequences that particularly affected the common man. The increased prices directly impacted households, leading to a rise in the cost of living for the common man. Additionally, businesses faced higher operational expenses, leading to economic challenges and job uncertainties. If gas demand spikes due to the polar vortex collapse, the energy crisis could worsen. Unpredictable and severe weather conditions can lead to an increased need for heating, putting additional strain on energy resources.